Okay, this is section 4.2 in your textbooks. We're solving multi-step equations. A little blurb at the front. Tim? All right, Matthew here in the front.
Look at the shapes in the bridge. The beams that form the triangular structures are called trusses. These are very useful in engineering and architecture because they add strength and stability to structures such as bridges and buildings. Where else are you likely to find triangles in common settings? How can equations be used to describe geometric relationships and to solve problems?
Good. So these things here we're talking about are called trusses in here, okay? And as you can imagine, they're just providing strength and structure between those two big long pieces that are running across the length of the bridge. All right, the investigate says, how can you use equations to model and solve problems? So these two triangles, here and here, have the same perimeter. So we all know what perimeter is. It's the addition of all three sides. Okay, you can use the equation 5x plus 3 is equal to 3x plus 7 to model the situation and find the side lengths of the two triangles. So let's see, where does he get the 5x from? Yeah, Adam?
The side lengths 2x plus 3x.
Right. Now, not quite sure why he or whoever wrote this textbook decided to combine those two like terms right off the bat, as opposed to showing, really it's this perimeter, which is 2x plus 3x plus 3 is equal to this perimeter, x plus 3 plus x plus 4. In any event, he decided to skip that step and to just combine the like terms. So this becomes 5x plus 3, and this becomes xxx, 3x, and 3 and 4 is 7. Okay? It says solve the equation by isolating the variable on the left side of the equation. Explain your steps in words and algebraic symbols. So here's our equation again, and I'll write it over here. A little bit more space. Okay, it wants me to isolate the variable on the left-hand side. So what would I do? Hugo?
What you do is you'd subtract 3, you'd bring 3x over, so you'd subtract it.
Very good, yeah, I'm going to throw
5x subtract 3x.
Excellent. Okay, and what am I going to do with this 3 here?
And the 3, you can bring it over to the 7, so you subtract it.
Excellent, so it's changing signs. So I have this equals 7 minus 3. Any questions there? So I'm moving on both sides of the equal sign then. Adam?
Does it matter if you go negative 3 plus 7?
No, it doesn't matter. Still going to give me negative, it's still going to give me 4, right? Positive 4. So now I have 4 and 2x. Okay? What's next? Christian in the back.
To get x by itself, you would divide 2x divided by 2.
Excellent.
And then 4 by 2.
Okay, any questions there? All right. So explain your steps in words and algebraic symbols. So to explain it, we moved variables or constants away from the variable terms, and we moved the variable terms together and then combined them, right? Moving over an equal sign, we were sure to change the sign of either the variable term or the constant term. Okay, Max, we're going to do the same thing now, except we're going to isolate the variable on the right-hand side. So I'm going to rewrite it out for you. You're going to tell me what to do next, Max. So we want the variables on the right. So what am I going to do? No? What's a variable?
The variable is the x.
Okay, good. So we want to isolate the x on the right-hand side. So am I going to move this 3x?
No.
No, it's already on the right-hand side. When I talk about right-hand, left-hand, I'm talking about from the equal sign, right? So what am I going to do with this 5x, Max?
You should probably keep that there as well.
No.
No?
We want to combine it, right?
Also make it negative 2x on the right hand side.
2x?
Negative 2x.
Right, well, yeah, once it comes over, it's gonna be -5, and then combining with the 3 becomes -2x. Good. So we'll just take it one step at a time. So we're gonna move that over and move this 7 onto the left-hand side. So we have 3 minus 7 is equal to 3x minus 5x. Good, so you told us this side already was -2x. And what's 3 minus 7, Max?
-4.
Okay. Now what do we do, Max? Sorry.
Then you divide -4 by 2.
Okay, +2 or -2?
-2, sorry.
Okay, good. Those cross out, and I'm left with?
2.
Good. All right, so look what happened. We ended up with the exact same answer. Okay? So you can work either on the right from the right-hand side and left-hand side. Generally speaking, we always keep the variables on the left-hand side if we have a choice. Okay? Or if it's kind of set up that way, we always want to move them on the left. Just kind of makes more sense to say x equals 2 rather than 2 equals x. Okay, it just kind of seems backwards. But we can do it this way. Okay, sometimes it's convenient. Later on in grade 10, you might see where, just a positive y is on the right-hand side, and that's all you want to solve for, so you just leave it there. Okay, rather than making it negative and then dividing by negative. So sometimes it's convenient to keep it on the right-hand side. Okay, but generally speaking for you guys, and as we go through these problems, we're going to keep it on the left-hand side, the variable. Okay, any questions? Yeah.
The step that you move the variable on the other side, you just do it all in one step where you put the, I don't know how to word that.
This 5x over here, when I move it over?
Yeah, when you move the 5x over, you on the same step, you move the 7 on the other side.
Right, yeah.
All in one step.
I do them all at the same time, yeah. Okay. Next, reflect. Compare your results from steps 1 and 2. Explain how you can collect like terms to solve equations with the variables on both sides. So we just talked about that. Describe how you would use the solution to the equation to find the side lengths of each triangle. So how would we find the side lengths now? Yeah, Justin.
You'd plug in 2 where the x is on the triangles.
Exactly, yeah. So this side length would be 4, this would be 6, and this would still be 3. This would be 2, this would be 5, and this would be 6. How can I verify if my answer's right? Luca in the back. No? What does it say at the very beginning, Luca? It says the two triangles have the same perimeter.
Oh, you could see it if it's the same.
Yeah, I can add all these sides up now, right? So this is 4 plus 6 is 10, plus 3 is 13. This is 11 plus 2 is 13. So that's my perimeter. It's the same. Okay? Make sense? All right. Let's move on. We've got 3 examples. First one, Sal. 3x plus 2 equals 2x minus 4. What am I going to do?
Okay, so you're gonna just collect 2x and 3x and
Mhm.
make it 5x.
No.
Oh, wait. As if it's not 5x minus 2, right? The final answer.
No. I don't know. I haven't got there yet. You don't want to just go to the final answer. You want to take it step by step, right? So what's the first step? We want to isolate.
Let's let the variable.
Good. We're going to isolate on the left-hand side or the right-hand side?
The left.
Right. Okay, so this variable is on the right-hand side, so we got to move it over, right?
Yeah.
Okay, so it becomes 3x minus 2x, right? Because it's positive here, and as you move it over an equal sign, it becomes negative. You remember that? Okay, now what are we going to do with this 2?
You're gonna bring it to the floor.
Right, move it over. And the sign changes from positive 2 to,
Minus, so.
right,
Negative 4 minus 2.
good. So then, what's 3x minus 2x?
Just x.
Good. And minus 4 minus 2.
Negative 6.
Excellent. Okay. They show here in the book this opposite operations. Whatever you do to one side, you have to do to the other. So you're getting rid of the 2x over here. So you subtract 2x. Subtract it from both sides. Anybody prefer this, or does everyone feel comfortable with moving over the equal sign and changing the sign? Who prefers this opposite operations? You prefer it, Tyler? Yeah? Okay.
I just find it easier, like, just knowing.
Alright.
I'm doing it for both sides, I guess that's
Okay. You gotta eventually let it go,
Yeah.
though, okay? Because it's a lot quicker to do it this way, all right? So you're gonna wanna just try and get comfortable with that. All right, Joseph, here in the front. 7 minus 2k equals 8 minus 5k.
You have to bring the 8 over on the left side, or you want the variable on the left,
Mm-hmm.
so negative 5k over the equal sign, so it's positive 5k,
Mm-hmm.
and then positive 7 over the equal sign is positive 8 minus 7,
Okay, good.
and then it becomes 3k,
Mm-hmm.
3k plus 1,
Mm-hmm.
and then
Now what?
3 divided by 1, or
3 divided by 3.
3 and then 1 divided by 3.
Good. So k is equal to 1/3. Okay? Got it? Gotta practice. AJ, next one.
C?
Yep.
Okay, so 3m plus 2m, negative 3m plus 2m,
Good.
then negative 2 minus 5,
Good. Okay, now what?
m on the left side,
No. Not positive m.
negative m,
Good.
then 7,
Negative 7. Right? So m is equal to what?
negative 7,
No. Positive m now. You gotta divide both sides by negative 1, okay? So these.
7.
Yeah, good. Yeah.
So sir, if the variable is negative and the answer is negative, can't you just automatically just change it
Yeah.
from that?
Yeah.
So,
Yep.
why did you put it over or divided by negative 1?
To get rid of the negative sign in front of the m.
But if it's two negatives, can't you just make it a positive? Or you have to do
No.
Okay.
You can, like, say m is equal to 7, because negative m is equal to negative 7. You can make that inference, but you can't just say it's not like a negative divided by a negative is positive. No, they're both on opposite sides of the equal sign.
Okay.
So technically, you have to divide them both by negative 1. Okay? All right, we're going to try and quickly get through this last example here, example 2. So here we're expanding now. We're using distributive property. Who haven't I asked? Michael. 2a.
So it would be 5y
Yeah,
minus 15
good.
and then negative y plus 2.
Excellent. Equals 19. Now what? Now what?
So then you switch the negative 15
Mm-hmm.
with the negative y.
Yeah.
So it would be
Let's
negative-
just do the variables first. So on the left-hand side, what are we going to have left? 5y and negative y. What will we have?
you would have
It's okay. Hold on, guys.
y.
Right? 4y.
and
Okay.
then
And then on the right-hand side, we're gonna have 19. What happens to this 15?
You added 2 to make it negative 13.
Okay, and then that comes over and it becomes positive 13, right? So 4y is equal to 32. Y is equal to 8. Okay? We're gonna continue.